Today I'm going to go over generic classes. And when you think of generics in Java, think of flexibility and type safety. So you have type safety with flexibility. You have those angle brackets that you've seen already with a list and the sets and the maps. We put a data type in there, and then the list becomes a list of that data type, and that gives us some type safety. We're going to do that with a custom class. And I got my project over here, project 20 generics. And I got one package, one class, a main method, and I want to make a custom object that stores 3 values, but it can store anything. It can store ints and doubles. Let's go ahead and do that. Let's go to this package right here, right click, new class. I'm going to call this my data, and I'm going to give it 3 member variables, private. I'll say object. That way I can stick anything in there. Object val1, private object val2, and oh my gosh, they're private object val3. All right, so no type safety, but we do have flexibility. This is the primitive way of doing it. Java 4 and prior did it this way, right? So let's go to source. And we'll make a constructor using fields. That looks good. Source, getters and setters. Let's add them. Right. That looks good. And then source toString. All right, so we'll do a Control-Shift-F. Make that look good. And go back to our app. Let's use it. Let's say my data. I'll just call it my data for my variable, for my object, my data. And I'm going to pass in an int, a string, and a double. All right, good. So it kind of works. Let's just go ahead and do a sysout and print. It's got a toString in there, so we can print out our data. I'll run it, and here we go. All right, problem solved. But there's no type safety. You might be like, so what? Why do you guys talk about type safety? Well, let's take a look. We'll have int val1, my data, get val1. All right. Now the fact that we see this error right here is really good. We don't want to see errors at runtime because that could be a long time. The code base could be huge. We might not catch that error until the customer is there. So we want to catch errors here. So we'll say, oh, that's good. It kind of knew that something was going on. We have to cast that object to an int. All right. And we'll go ahead and do it again. We'll do a string, str, let's do val2. Val2, and I'll do my data, and val2. Oh, good. Well, look at that. Cast to string. See that? Everything's going fine. But now I'm getting tired. Maybe I'm not even in this class anymore. Maybe I'm using my data somewhere else. Thousands of lines of codes later. And I say int val3. See that? I did that int on purpose. It should be a double, right? My data get val3. Oh, well, let's see what this is. Cast to int. See, it's looking at that. That's why it's telling me to cast int. It just knows object in here. It doesn't know anything more than that. Now everything's looking. I got these little warnings saying I'm not using it. Let's go ahead and use it so we can get rid of that yellow there. Plus and val2 plus comma val3. All right, we'll save it and let's run it. Oh man, double cannot be cast to integer. So this is a tiny little program, so we were just able to run it and see the error. But if you had like a million lines of code and you were pushing it to your build server, it might be 45 minutes and you might not even find the error if there's no code coverage here. So that's why we have type safety. Catch the errors while you're programming. All right, so let's go ahead and add our generics to our class. Let's see what happens. See how much safer this is. Let's go to my data. So I click on my data, and we're going to do those scary angle brackets, right? And you use capital letters for this. They can be any capital letters, right? T, S, and V. You can use a regular variable, but that's the convention, a single capital letter. All right, now object becomes, you make the data type that capital letter. So essentially you're just passing in your data type. That's pretty cool. This would take a little bit of time, so let's just go ahead, delete what we have. You don't need to delete the toString. And we'll generate another constructor with this new data. Look at that, it knew to use my T, S, and V. Let's add some getters and setters. Generate getters and setters. 1, 2, 3. Look at that, T, it's returning the types. So that's good. These are generic types. Awesome. Let's go back to our old code. Let's say my data was written 5 years ago. It's all over the place, and you want to make it type safe. You just did that. Did you break anything? Let's see. Oh, you know, we got to fix our error though. We got to get this double again. We don't break anything. You're gonna have to take my word for it. Let's just go back to double here. There we go. Now it runs. Yay! It didn't break anything. The only thing that was broken was the thing that we broke intentionally to show that the types were not safe. All right, but I am getting a warning, and it says, hey, you should parameterize my data with these data types. That way we can make it safe. So now we'll go integer, and there's a string and a double, all right? We'll go over here. We'll just add open, close, angle brackets. If you're using Java 8 or past, you don't need to put the data types over here, right? Everything's looking good. Now look at this. It'll run like that. We haven't broken anything. If I get rid of these data types, I'm good to go. I have no problem, right? That's convenient. And we'll save that and run that. Looking good. Now if I make this mistake, int, boom, I see it right now. I don't have to worry about some error that's going to happen in 3 weeks from now. And this is essentially an int. This is exactly an int, right? I can just do a, what is it, int value. Makes it an int, no problem. So everything I do with a double, I could do with that. That's pretty handy, right? When you have an object, you have to cast it to the double and do all that other stuff. So we got type safety and we got the flexibility. Whoops, double, it's back to where it was. Let's make one more. Let's make one more of these. So Control C, Control V, and we'll put a string in here. And we'll do something crazy. Use the old J frame from Swing just to show that you can put like some weird data type in here. That's the old style Windows. I'll go ahead and import it. And let's change these over here. What do we have? A string. Let's put a string. String, my string. And we'll just instantiate a J frame right here. New J frame. And looks like it's going to work. And we can't do my data twice. We have to give it a different name, slightly different name. Now we can't really print out the J frame. It'll be crazy, but that's all right. We'll do it anyway. There's no toString in J frames. Well, there is, but it's the default. There we go. So we got our string, we got our Pete, and then we got this unformatted J frame string that came out. But everything's working, right? We're good. We don't have to worry about any data types biting us downstream weeks from now. Any errors we make now with data types, we're going to see them right away. And that's the power of generics, flexibility with type safety.